Okay, in this video we are going to talk about symmetry, about how we can identify symmetry. And I think most of us kind of have an idea of what symmetry is, even if we can't necessarily enunciate it and say it clearly, right? Because it's a pretty common thing in nature. You know, a lot of things grow symmetrically, right? You know, leaves tend to grow symmetrically, like our body is very symmetrical. You know, you can kind of go down the middle, like of your face, and it's you got a nostril on each side, you got an eye on each side, you got an eyebrow on each side, an ear. I mean, it's not perfectly symmetrical, but the idea of it's there, right? And so that is that example in particular is an example of something called line symmetry, right? So you have matching halves. They're basically reflections of each other. They don't look exactly the same, but you can kind of take it. The way I think of line symmetry is I can take this graph right here, right, and I can spin it on this axis of symmetry, which is something we'll talk about later with quadratics. You can spin it on this 180 degrees if you think about it in 3D, like coming around in space and coming around there, and it would give you the same thing, right? It's going to give you the same thing, right? It's 1 unit away here, it's 1 unit away there. It's 2 units away here, it's 2 units away there. And it's going to basically give you a mirror image. So if you can think about it like that way with mirror image, right? That's probably the best real world way to think of what line symmetry looks like, okay? Now when we talk about point symmetry is kind of a different thing. And so what it says is there's a point that the graph can be rotated 180 degrees, and that's important. 180 degrees is like, it is a half circle, right? Half the distance of a circle. So it's like the same as you facing one way and then completely turning around the opposite direction, right? 180 degrees around to map on itself. So when you spin it 180 degrees, it looks exactly the same as what it looked like before. And that's really interesting, you know, if you think about that. But it's like if something has point symmetry, you'll be able to do that, and you'll be able to see it. Now, if it can't do it in 180 degrees, then it does not have point symmetry, right? Because obviously every graph you can spin 360 degrees around, and then it will map onto itself again, right? But that's not what we're talking about. We're talking about this has to be able to do it at least once, right, before you've made a full rotation, right? Because obviously it's going to be the same if you go 360, right? But 180 degrees is halfway, and so if it's the same thing when you've gone halfway, then we call that point symmetry, all right? And so let's start looking at some examples of that, all right? And it says identify the symmetries, if any, in each function's graph. All right, so when I look at this first one right here, okay, it looks like I'm checking it out, and it looks like, you know, it's got, well, this is kind of going up over here, and it's going up over here, and it kind of comes down to a point. Looks like it's about, you know, 3.5 units or so away. This one's about 3.5 units or so away. They're about the same distance. So if I continue to analyze this, hopefully you can see that, yeah, if I can split this right down the middle, right down the x-axis, right? And so this thing has, I'm going to write this in something that you can actually see. This thing has line symmetry, and it has that about the line x equals 0. That's this line right here. This is x equals 0, which is another way of saying the y-axis, right? That's our friend, the y-axis, right? But it does have line symmetry. It's a mirror image. Another way of thinking of it is I could actually fold it over this line, and if I folded this over, right, if you put this on a piece of paper and I folded this right here, this would map right on top of that. It would lay right on top of that, and you'd be like, oh, cool, looks the same. And that's because it is the same, because it has line symmetry. All right, now this one says, okay, right over here, does this have any symmetry? Well, it obviously doesn't have any line symmetry anywhere, because no matter where, like if you drew a line like right here, right, then you'd be like, well, no, because if you fold this over here, this is going to be looking more like this, going up in that direction, right? And that's not line symmetry, right? That's something else, right? So this does not have line symmetry. However, if you go on any point, right, if you take this point right here and you spin it 180 degrees, it is going to wind up over here, right, depending upon what you do. And with these, it doesn't matter where you spin it on. You could spin it on this point, and this would map on itself. You could spin it on this point right here, and it would map on itself over here after 180 degrees, right? So that's 180 degrees. If you did this one here, it would map on itself right over there, right? Or sorry, I put that in the wrong spot. It would map right there for this first one. Second one would map right over there, right? If you went one more, it would do the same thing, and it would map over here. And so hopefully you can see that you've got every point on this side right here is going to map over on this side after 180 degree. So this does have line symmetry, or not line symmetry, my bad. This has point symmetry, right? Has point symmetry. Okay, so yep, that's your point symmetry, and it has point symmetry about every point, right? It doesn't have a particular point, right? Point symmetry about every point, right? So any point on the graph that you can find, you can take this graph and spin it around 180 degrees, and everything else is going to map on top of each other, okay? All right, let's look at this one. Well, this one, it looks like this side right here, so if we kind of split this, right, like right along there, it looks like this side over here appears to be the same as this side. It looks like it's going up the same distance, it's 1 for 1, and it's doing the same thing over here. Goes over 1, up 1, just in a different direction. So this is a mirror image of this. And when we have that mirror image, that is when we say we have line symmetry. Okay? And that would be about the line x equals 1. Right? And that another name is either an axis or a line of reflection. Right? Because that's kind of what symmetry is. Symmetry is reflection, right? Mirror reflection, mirror image. Okay, this one right here. So if you look at this, this is obviously it does not have any. It's very different. Like after it crosses the y-axis here, right? So but it's not line symmetry, right? But there is something cool going on here, and we do have some kind of symmetry, because if you think about this, if we take this thing and if I put a pin right in this right here, and if I could kind of break this loose from the graph and sort of spin it, it's going up and down, right? And if you imagine it kind of going like that, and it's going to continue to sort of go like that as we go around, right? As we get closer and closer, right? And then it's going to wind up like this, right? So this has what we're calling point symmetry, right? And it has point symmetry about that point we identified right here. So the point that we're looking at that's giving us our symmetry is this point right here. And we would call that point symmetry about, and then you just list the coordinates of it. So your x-coordinate is 0, right? And then your y-coordinate is 1, 2 units up, right? And that is your point symmetry. So line symmetry is, mirror image. Point symmetry, think of like a spinner, right? If you like on a child's game, you have a spinner, right? And when it goes 180 degrees, it give you the same thing, right? So there you go. Hope this is making some sense to you, and good luck with these.